Thank you.
Thank you, Sean, for inviting us. I would like to thank General Das for giving us an opportunity to present our research here today on behalf of ARCIC. Good afternoon, everybody. My name is Anit Giri. I work at the U.S. Army Research Laboratory, ARL. I am very, very excited to be here, like all of you. I'm going to show you some amazing research on some new material we have developed, which can produce hydrogen, pressurized hydrogen on demand in the field. You see this block. 36 of such aluminum blocks made of our aluminum powder, 36 of such blocks, like a 6 by 6 arrays. So that is the volume of such aluminum blocks. Sorry, I'm sorry. Oh, it is already there? Sorry, never mind. 36 such blocks can generate enough hydrogen in field and compressed to run this Army vehicle for 140 miles. So how this is possible? Let us see. So at the U.S. Army Research Laboratory, as a team, we discovered an aluminum-based alloy powder that reacts with any liquid that contains water to produce hydrogen very, very rapidly. That any liquid could be pond water, drinking water, river water, sports drinks, coffee, tea, and urine. This will react very fast and generate hydrogen at room temperature. So that hydrogen gas could be fed in a fuel cell or fuel cells to generate on-demand power for soldiers and vehicles. In this video, sorry, which one is, okay, never mind. In this video, you see the 5 liters of hydrogen was generated in probably 30 seconds or so. It's 5 liters of, oh, it cannot go there. Sorry, never mind. So what is new? It is very well known that making hydrogen by reaction with water, everybody knows it. But it requires nasty chemicals like, say, acid, hydrochloric acid, base like sodium hydroxide, and expensive and toxic catalysts, or some metals like gallium, which are toxic and expensive. With our powder, nothing, none of these are required, nothing. Just this powder, which you see here in my hand, and this water. No, I'm not going to drop it. But if I add this in this, hydrogen will be generated right now, right here. And if you cap this, then you will have compressed hydrogen. It is so easy. So since we do not use any sodium hydroxide, any acid, or any toxic materials, either in this or either in this, the byproducts are very non-toxic. It could be disposed of anywhere. The byproducts are mostly oxides or hydroxides of aluminum. So it could be disposed of right here in the field, in sea, whatever we want to. No toxic byproducts. That is very important. The reaction rate is the fastest reaction rate. We get about 1 liter of hydrogen per gram of aluminum, which is about 75% of the theoretical yield in 1 minute. And in 3 minutes, we get 100% theoretical yield. So the reaction rate is very, very fast. So why the reaction rate is so fast? This is because, you can see here, we have generated a nano-galvanic structure. That is a galvanic structure between aluminum and other elements in the nanoscale. I should mention here, these powders, the structure is nano. They are nanostructure powder. but not nanoparticulate powders. So there is absolutely no inherent inhalation hazard. These are like any other metal particles, nothing nano. Also, I should mention in this context that there are other powders available which are nanopowders. They also produce hydrogen gas, but they are coated with some chemicals. So they could be toxic. So these are nothing, just this powder and water, and the powder is safe, very safe. So the process we use to make this powder is very, very scalable, easily scalable. Unlike other powders that contain, or other aluminum alloys that contain gallium or other elements, our powders, we can make mechanically strong structural parts out of our powders by using conventional metallurgy or 3D printing. Any parts could be made. Very stable structure. Others you cannot make a stable structure. And it is 3D printable. And as you see here, these powders are very stable. You see that flame temperature is 2200 Fahrenheit. The powder glows. It is yellow. You see, it is yellow. It glows. But it does not catch on fire. It does not burn. Other powders will not do. Aluminum hydride is also a source of hydrogen gas. That will not do this. Of course, JP will not. JP8 will not. So you see, those powders are reusable. So now we are scraping off the powder and dropping it in the water, and hydrogen gas is formed immediately. Violent reaction. So they are very stable powder, safe and stable. So stable against incendiary attack. JP8 is not, or other powders are not. So why aluminum as an energy source? Because mass basis aluminum is 28 times more energy dense than the batteries. And by volume, it is 20 times more. In this landscape, energy landscape of volume on the y-axis and mass in the x-axis, you see it is in the corner. The batteries are at the corner, batteries. And here is aluminum at the top. So they are very energy dense. So this weighs about 2 pounds. So the energy content of this aluminum is same as the energy content of 60 pounds of batteries. So we can make small pellets. Soldiers can make small pellets out of this powder, like tablets, and carry in their pocket. Just take it out, tear it, take it out, drop it in water, make hydrogen in the field, and generate power. Logistically, JP8 is pretty expensive, and it could be more so because you have to transport it, if you have to transport it in remote locations. JP8 is very difficult to airdrop. Aluminum being solid and powder, you can make compacts, and being very energy dense volumetrically. In a small volume, you can transport huge amount of energy, massive quantities of energy, and it could be airdropped in any locations. And the flexibility of using any liquid and any water, pond water, any liquid, including urine, to generate power makes it even more attractive or easy to generate power on demand in the field at the point of need. That will make our soldiers more self-sufficient, and this will reduce the logistic resupply requirement, and the extension of the mission would be much easier. The amount of fluid we spit each time is capable of generating 1 liter of hydrogen. So now let us imagine how much water we use when we shower or flush a toilet, if those waters could be stored and used. There is a pond in Kandahar airfield called Black Water Pond in Afghanistan. Such water, like 30 million gallons of water per month, is generated there, and they are stored there. So of course, with appropriate quantities of our nanogalvanic aluminum alloy powders, we can generate huge quantities of hydrogen, which is sufficient to generate energy that will power 500,000 US homes, average US homes, for 1 month. So huge source of energy using this nanogalvanic aluminum powder and any water. Another thing, important thing, is that unlike many other aluminum alloys which exist now, we can make our aluminum nanogalvanic aluminum alloy using scrap aluminum, which is available which may be available in the battlefield with aluminum cans or battlefield scrap. And using this scrap aluminum, we can make nanogalvanic powder at the point of need in field. And then hydrogen could be generated, and power and energy could be generated. JP8 cannot be made in the field or at the point of need. So our research has attracted attention from various people around the world, various organizations. It came to many newspapers, some TV, and for our public affairs office until January. This has received about more than 52 million hits. So, in conclusion, we believe that ours is a disruptive discovery. What we need is this, and any liquid that contains aluminum to generate hydrogen very, very rapidly and at room temperature without using any other nasty chemicals or any other thing. And that will make on-demand and in-field power generation possible. And we believe that our technology has the potential to dramatically change how the DoD or Army mission is conducted. And as General Dias mentioned, that power and energy generation at the point of need is an important aspect of demand reduction. And we believe that this will be a step closer or further to achieve this thing. I thank you for your attention, but I would like to show you a video. Do I have, how much time I have, sir? Okay, so I have a video for 3 minutes. I want to show you because many of your questions could be answered here. If not, then I will answer. And our booth is the fourth one from the right, where we have the demand reduction white papers. And we are showing some demonstrations here. Please come to our booth and...
Army scientists add a newly engineered nanopowder with urine and observe unexpected results. Hydrogen releases from the urine at a fast and furious rate.
As an Army scientist, we try to develop new materials and technologies that will benefit particularly the soldier in the field.
The research team announced earlier this summer that a nanogalvanic aluminum-based powder they were developing produced pure hydrogen when coming into contact with water. The researchers then observed a similar reaction when adding their powder to any liquid containing water.
This powder, which we have discovered, reacts very fast with water to produce hydrogen.
Hydrogen, the most plentiful element in the universe, has the potential to power fuel cells and provide energy to future soldiers. Fuel cells generate power by channeling hydrogen through a series of membranes that split it into positive protons and negatively charged electrons. At the cathode, the electrons and protons combine with oxygen, resulting in electricity, water, and heat.
Using the fuel cell, you can generate power. 1 kilogram of aluminum powder can produce 220 kilowatts of power in 3 minutes.
In space, astronauts recycle wastewater and urine because drinking water is a precious commodity. For soldiers in austere environments, there are many precious commodities, but power and energy is increasingly important to run communications and electronics gear, and urine is usually not in short supply.
When we demonstrated it with urine, we saw almost a factor of 2-fold increase in the reaction rates. And so in some ways, we're all very excited because it opens it up for additional potential applications that the rates are so fast and so efficient.
The team is still investigating why urine causes a faster reaction, but it may have something to do with the electrolytes and the acidity of the liquid, they said.
I'm excited about it because it was sort of a spontaneous finding. We weren't expecting to develop this material specifically for hydrogen production, and it was a group effort.
In a statement, the laboratory director, Dr. Philip Perconti, said it may find great utility for forward deployed troops who need a compact and lightweight energy source.
We've had an overwhelming response to at least the initial video that we released, and we've been having industry partners, multiple industry partners contact us inquiring about potential licensing. We've had numerous universities contact us. Army partners have also reached out to us.
In the coming months, the team will continue to investigate and push the limits of the discovery to try and understand its implications. From Aberdeen Proving Ground, Maryland, David McNally, ARL TV.
So we have time, and if you have any questions, I can answer, but I will be in the booth all the time, all day today. Efficiency of the fuel cell?
No, you have to put energy into the aluminum nanostructure somehow, right?
Oh, okay.
So
So
based
you are
on the
trying
energy,
to say what is the cost kind of thing?
what's the overall efficiency? You put energy in, how much of it comes out?
Oh, like when we make the powder, including all those efforts?
Right, you're using electricity, I'm assuming, to make the
Oh,
material?
okay. No, we are working on that, but we do not have any particular number for that. We know some idea about the cost, but what energy we are getting, we don't know. But we know that the cost of this, we have not calculated those things yet, because we are still in the 6.2 kind of research state. We are working on that.
Okay.
But we have some idea about the cost efficiency, yes. Other questions? What is that?
Are the slides available afterwards?
Oh, yes, yes, yes. Yes, of course. Of course, you can give me your card or something. I can send it to you. Of course, yes, yes. These are all approved for public release. Okay, then I thank you for your attention. Thank you, thank you.